they can join us. So really, we're not talking about a whole lot of calculus. We'll talk a little bit of calculus, but we do need to remember a little bit about parametric equations. So parametric equations typically describe motion. Okay. Most common variables you will see for the parameter, hence the name parametric equations, will be t or theta. Theta typically when we have angles to plug in, t typically when we have time to plug in. T will not always represent time, but in a practical setting, it will. Okay? But what we're going to do is we're going to write our coordinates as functions. So instead of one function where we plug in to get a coordinate, we have x as a function, y as a function, and that's how we get our coordinates. So we plug in our parameter. In this case right here, t, we'll plug in a value for t to get an xy coordinate. Plug in a value for t, get an xy coordinate. Okay. You would have talked about parametric equations at the end of pre-calculus, which was 2 years ago. All right. So, throwing that up. Okay, so we're going to talk about two different ways of coming up with a graph for a parametric equation. The first one is creating a table. So go ahead and write down this here.
Yeah, she is.
Okay. I can see your stuff.
They took it down to the pictures because they came straight from history.
Oh, gotcha. All right, so in this example, I give you a specific domain. T is going to start at -1 and it's going to stop at 4. So we can make a t, x, y chart where we're going to plug in -1, 0, 1, 2, 3, 4, all in for t. Okay, so this is kind of boring and tedious, but simple math. So when we plug in -1, we get 0 for x, -2 for y. When we plug in 0, we get -1 for x and 0 for y. When we plug in +1, 0 for x, +2 for y. When we plug in 2 for t, x would be 3, y would be 4. When we plug in 3, =8, 6. And when we plug in 4, 15, 8. Okay. I know this seems kind of, like I said earlier, tedious, but I want to really make it a point and remind you what makes parametric equations special. Okay. So if we plot these points in the order in which we found them, okay, when t was -1, we had 0, -2. Then we had -1, 0, 0, 2, 3, 4, 8, 6, and 15.8. Okay? When you graph a parametric equation, it does matter the order in which you connect the dots. So since this was t equals 1, then, negative 1, 0, 1, 2, 3, 4, we're going to draw them in that order, and then we're also going to put arrows saying that that's the order in which they would be drawn. Okay? So if we're looking at a regular graph and a parametric graph, you should see a difference because the parametric graph will have direction. Okay? Joe.
This is just a cycles graph.
Okay. So then that brings me to my next point. Plugging in random numbers is not always going to be an effective or efficient way of graphing a parametric equation. Okay. So I want to remind you of the algebra behind how to figure out what that graph's going to look like without just plugging in random numbers. Now here it was okay because I gave you a specific domain. Here, I have this. Now, I have this written down right here. Would I actually need to say that?
No, due to the domain effects.
Okay, so right here, we would already know that t is greater than or equal to 0. And I would expect you to identify that and think about how that would affect our result. Okay, so our second option would be to actually convert this into a rectangular equation. Okay, when I say a rectangular equation, I mean an equation that is in terms of x and y and we graph on our rectangular plane. Okay, so we know that, well, this is easy, right? Y equals t. Okay, if it's not as simple as this, solve for t in an equation to plug it into the other. But right here, we've already got that taken care of. Y equals t, so x equals the square root of y. Okay, that's probably not comfortable for us to see. It's probably not comfortable for us to see that x equals the square root of y. More than likely, you would change it to y equals x squared, which is fine. However, you would need to specify that x is greater than or equal to 0. How do I know that?
Because when you set, you can set x squared equal to t, and because t is greater than or equal to 0, then x also has to be greater than or equal to 0.
Okay, we have to go back to our original domain. Okay, we cannot plug in any negative values for t, which means we're not going to have any negative values for x either. So when we graph this set of parametric equations, we are going to have half of a parabola, the positive half. Get out your calculators. I think that's what I have next. Let's see. Cross your fingers that my calculator won't mess everything up.
We need the following groups to go to the gym for group photos: mock trial, National Honor Society, quiz bowl, and robotics. Again, that's mock trial, National Honor Society, quiz bowl, and robotics.
Goodbye.
And then there were two.
And then there were two.
Are you
Yep.
required to go to pictures?
I mean, you don't have to be, but if you're in one of those clubs.
I don't want
You don't want to take a picture?
to. No,
Okay.
I don't want to miss too much school before.
Before you have to miss school. Okay. Okay. So, if you want to graph in your calculator a parametric equation, you would first have to go to mode and change your mode to to parametric mode. Okay. Why does my graph look like this? There we go. Okay. So we're in parametric mode, and so when that happens, if you go to y equals, you'll have like the x equals and t equals. So what was our equation? X equals square root of t and y equals t. Okay. Now, if you go to window, you'll see that your calculator automatically sets this to be t equals 0 to t equals 2 pi. Okay. So if you wanted to look at something different, you would have to change, like, that first equation that we did. Will you remind me what this first equation is that we did?
X equals t squared minus 1. Y equals 2t.
2t. Okay. So if I were to graph this right now, you would only see, you would only see half of that parabola because my calculator is automatically set at 0 to 2 pi. So if you wanted to see all of it, you would have to go to your window and change your t min and your t max. So if I said like -10 to +10, you would see all of it. Okay. Now I want you to pay attention to when you actually graph it. This thing graphs really quickly. But when you graph it, like square root of t and t, it will graph it in the order that the arrows should go. Does that make sense? Mine, this is graphing really quickly. I believe like the 83 and the 84 would graph a little bit slower. Does yours graph as quickly as mine did, Joe?
Mine graphs really fast.
I know. It was hard to tell, so you got to pay close attention. Watch closely. Okay? But I want you to know how to do this.
Why'd you just, there's 2 people in here.
Well, there were 4.
Just make them watch the video later.
I don't have a video unless I teach
We
it.
had to put it in memory of you. It was like, rip Miss Holman.
See you tomorrow, Caleb.
Yeah.
Welcome back.
Thank you.
No, we went from 4 to 2 to 3. We'll eventually get there. Okay. All right. Ooh, we should make a code word while we're in the middle of this.
Exploding pineapples.
Exploding
So
pineapples.
I
Okay.
don't know, but it's always pineapples. Yeah. Pineapples is the main one I hear. Yeah.
Yes. Yes.
Except that one day we were like, oh, Laffy Taffy.
Okay, so it is important to know how to graph parametric equations in your calculator because you could need that on maybe like the calculator portion of the AP test. You can still do everything like second calculate. You can calculate dy dx, dy dt, and dx dt, which we will talk about tomorrow. But dy dx, if I put in a value, it'll give it to me. Okay, but we'll talk about how to find those algebraically tomorrow. So, back to our notes. Please write this one down. Okay, so the strategy that I gave you over here was to solve one of the equations for t and plug it in. okay? And usually that's not going to be too big of a challenge, okay? However, when we have trig functions involved, solving for t is not going to be an option, so we're going to have to look at a different alternative. Okay? So your thoughts on x equals 4 cosine t minus 1 and y equals 5 sine t plus 2.
Graphing calculator. That's my opinion.
Okay. How about if we didn't have our calculator handy? Because your graphing calculator is not going to help us completely because we still got to write the equation.
Because honestly, putting it, just solving for t would make it into arc sine and arc cosine. That's probably just as bad.
Right, right. Do we have an identity that relates sine and cosine together?
Yeah, but they have to be squared.
Okay. What is that identity?
Sine squared plus cosine squared equals 1.
Do you think we could solve for cosine of t and we could solve for sine of t in these equations? Maybe. Okay. So I'm going to erase this quickly. So like over here we have x plus 1 and then divide it by 4 would be the cosine of t. Do you agree with that? Over here we have y, subtract 2, then divide it all by 5, and that would be the sine of t. Okay, so now what we could do is we could take, I'm going to write it in the order of cosine squared t plus sine squared t equals 1. And so then we can write cosine of t squared plus sine of t squared equals 1. Okay, flashback to pre-calc. What is that? Of a? Yeah. It's been a long time, so I'll help you remember. Okay, where's the center of our ellipse?
4, 5.
Yeah, we're going to take these numbers right here for our center, so negative 1, 2. But then,
Those
Joe,
are the radii.
the 4 and the 5 tell you how far to move out from the center. So since 16 is related to the x, we're going to move horizontally.
Those are the radii.
Well, I wouldn't call them the radii since it's not a circle, but we called them our vertices, like how far away our vertices were. And then 5 would be the vertical distance since it's associated with y. So now our last decision will be, where do we put our arrows? Which direction? We have a 50-50 shot. How can we make a decision knowing that we're right?
Clockwise is positive. It seems positive.
What would be a way to mathematically tell? Let's plug in 0. If we plug in 0 for t, we would get the coordinate 3, 2.
Yeah. 3.
Okay. Now, don't plug in 1 next. Well, I probably would avoid pi because we're probably going to get this point right here.
Pi over 2.
And so then we're not going to know, you know what I mean? So let's try pi over 2. If we plug in pi over 2, we get negative 1/7. which is here. So now we know going counterclockwise.
I mean, wouldn't you know that even if you plotted pi because it would be from this?
Well, but you wouldn't know if you needed to go this way or this way. Yeah. I believe you'll have a problem in your homework tonight that you'll have to be careful with, like this. Okay. Yeah, so Emily, back from pre-calc, okay, like this is the first example that we did where, and we'll come back, we'll get all the way through notes and then we'll come back for you to write this down, but as we plug in values for t, we plot points, and the direction of how we connect those points is important, so we signify that with arrows.
Okay.
Do you kind of remember graphing something like that in pre-calc?
I forgot about the
Yes. It's okay to forget, but remember from now on. Okay. So here's a little bit of calculus to satisfy our calculus hearts. A smooth curve. So when we talk about a parametric curve, we're now relying on two separate equations to give us one graph. Okay. So how does that work with basically points of non-differentiability? Okay. So we have a smooth curve if f prime and g prime are continuous and not simultaneously 0. So the font that I chose maybe wasn't the best because this is, it's an I. Sometimes there's just like a default font, so you just go with it and then it doesn't turn out as Smile pretty?
Sure. We are on our way back. I was on the end now. They haven't called anymore, right?
NHS?
Yeah, we just.
'Kay.
Oh my gosh. Crazy thing. People who weren't in NHS just slide into the picture. Miss Albright just. It was rough.
Well, I'm glad that she stood up for us. Welcome back.
Thank you.
Okay, so we're kind of coming to the end of our notes, but I'll go back.
How many minutes do we have? Maybe like 20.
They're 20.
So we can like go back through them while they're doing their homework.
Yeah, I can like play the video of myself talking.
Cool.
I'll just
I
come
don't know how
right-
I feel about taking notes after like not taking any for a couple 2 weeks. That's how long it was.
It was only like
A side
5
boy.
days because there was like the tests and then there was the project.
Yeah, so it was like a day of review,
There's like 2 days of review.
test. So
2
2
days
days
of
of review,
tests.
that's 3, and then
Around
plus the
reviews.
weekend, and then the tests is 2, so it's like 5. It was like 10.
Okay, so this is what's called a cycloid. And I'll show you what the cycloid looks like once we're done with the analysis of it. But basically, I want to determine if this is a smooth curve. And our definition of a smooth curve is that f prime and g prime are not simultaneously zeros. So let's look at this. Here's our parametric equation. What would dx dt be?
Two has two cosine.
Okay, and what would dy dt be?
Two sine.
You said this is 20.
This is the last example again.
Is there a lot of stuff? You know?
There's only like 2 other examples.
I'm just gonna add a little bit
Okay.
There's like 2, 3 other examples.
So if we look at where this is 0, I'm basically asking you where the cosine of theta is equal to 1. And when does that happen?
0, pi, 2 pi.
0, 2 pi, 4 pi, etc., right? Because at pi and 3 pi it would be negative 1?
Yeah.
Okay. How about when we set dy dt equal to 0? When is the sine of theta equal to 0? This would be all the pi's, right? And cosine equal to 1 would be all of the 2 pi. Okay. So, are these ever simultaneously 0? Okay. So this is not smooth.
That's piece 1.
So it's not smooth at 0, 2 pi, 4 pi, basically 2 pi n, right? It's not smooth at 2 pi n, okay? All right, I know you're dying to know what this looks like, right?
Skipping rocks.
It is like skipping rocks.
It's like birds.
And
It's birds, but all the birds are holding hands with
or it's like the start of a cloud. Anyway, we could do a lot of art with this. But what are these corners right here are when okay, so this is like 0 and 2 pi and 4 pi and 6 pi and 8 pi. Okay, that's where that happens. Okay? It's not. All right, so I'm going to stop the recording. Those of you who are here the whole time, you can start your homework. Those of you who just got here,